All right, let's talk IMA Bay componentry, particularly on this power delivery unit here, the PDU. First of all, this is where the IMA battery is, which has the nickel metal hydride cells in it. This is your MCM. There would be a BCM here in an OEM car. In this case, this pack has an LIBCM on it. This is the junction board, which is removable, and it has all of your relays and resistors and the battery current sensor and the a couple more relays, fuses, switches, and some capacitors. We're not really looking at that. We're talking about the PDU, which again is the power delivery unit. And what this is the left side of the IMA bay. The PDU is the DC-DC converter, which converts your high voltage DC bus, say 180 volts, down to the 12 to 14 volts that your car needs. This is in place of the original alternator. That's the right side of this unit. The middle here is a magnesium channel. This is one of those things where Honda was like, we're gonna make it out of magnesium to save weight, and then there's steel brackets all over the car. If you look inside of this, you can see that, get my light here, all the middle of this is heat sinks, so that you can cool these devices. Now it is interesting to me that they've given about, I don't know, 60% of the heat sinking area. You can see this line down the middle. The left half is the power stage that drives the motor. The right half is the DC-DC converter. They've given about 60% of the cooling cross-sectional area there to the power delivery stage, which is driving the motor, and about 40% to the DC-DC converter, which is really wonky because the power delivery stage is several times more power and waste heat compared to the DC-DC converter, which might be like up to a few hundred watts. The PDU can be like thousands, maybe even plural thousands of watts. I'd have to look at the math. But anyway, we're gonna look at the left side here. Taking this cover off is pretty easy. You remove a couple bolts. This is one of the few spots in the car where they're using 8mm bolts instead of the 10mm bolts everywhere. But anyway, yeah, you basically take this off. This is just your relays that actually turn the IMA system 12-volt rail on, and then also two of these relays control the fan that bolts onto the back of here. These resistors here literally just set the fan speed. This is a really dumb thing. They should have used a PWM chopper, but whatever. Those are that. To remove this cover, you basically have to remove this. There's a couple bolts hiding under there, and then eventually you can twist this off. And inside here, we'll find these are the 3-phase current sensors, which are measuring the W, X, and Y, I guess is how they have them identified. Let's see. No, it's UVW here, sorry. And so these are basically measuring each of the 3 phases on your motor to make sure the currents cancel to 0. When you add the currents on these 3 sensors, they should be 0, and if they're not, that's when you're getting errors specific to these sensors. Now the plus 40% current hack, the little PCB that goes on the MCM, which is over on the battery here, that's spoofing all 3 of these values. So anyway, that's what that does. If we remove this, this is the pre-driver unit, and basically this takes the 5-volt TTL logic from the MCM, which is controlling the phases. There's 6, there's a U high and low, a V high and low, and a W high and low. And this takes those ground-based 0 to 5 volt signals and translates them to the IGBT chopper, the IGBT chopper, which is underneath this, which is the actual power stage. And basically what this does is it safety isolates it. If you look at this PCB, if you shine it up to a light, you'll see that you can see through the PCB in a lot of spots. It's literally because all this is a translation error PCB. There's no logic per se. There are microcontrollers on here, but those are basically, there's the low voltage side and then the isolation side microcontroller, just so you can communicate across this isolation bus and translate it. Microcontrollers are good, but these microcontrollers aren't like preventing anything per se. The only thing they're preventing is when the overcurrent condition occurs on the IGBT stage. This is what's actually stopping the current and possibly setting a check engine light. But otherwise, it's completely dumb. The MCM is controlling whether or not the phases are high or low, and in normal conditions, this is literally just a translation layer. If we pull this off here, underneath this, we have the capacitors. So there's 3 honker capacitors here. I'll grab one, you can see them there, but I have a couple out here. This is a 1750 microfarad, 350 volt capacitor. And again, there's 3 of them, so quite a bit of juice in here. These hook directly up to the phase current leads, which is why oftentimes you'll see when you're taking the IMA battery out that they recommend that you wait a little bit for these to discharge, because if these have 200 volts on them and this is 5,000 microfarads, that can kill you pretty quick. We have an AC capacitor pack here, which is ground reference to the chassis ground. And then underneath that is the actual power, what do they call it? This is the power delivery, no, I'm sorry, this is the IPU here, the Intelligent Power Unit. So this is an IGBT driver. It's 6 IGBTs, and basically each pair is a half bridge. It's either controlling whether or not the phase is high or low. So is the U phase high or low? Is the V phase high or low? Is the W phase high or low? That's all that's doing. But again, that operates at very high voltage, the HVDC bus voltage, and therefore you need this isolation layer on top so you don't explode your MCM. Your MCM can't handle that voltage. So all this is doing is, it's translating the temperature from, this has a temperature sensor on it, it has an overcurrent sensor, it has the, there's the various sensors, but again, this is not doing anything intelligent per se. It's literally a translation layer. And then it's plugged directly into this IGBT. It's an IGBT, but Honda calls it the Intelligent Power Unit, the IPU. And again, this is the PDU, which is the power delivery unit here. So anyway, that's basically it. I think I have one of these readily accessible so I can show it to you out of the car. Yeah. Here is my test one here. So this is sitting right there down in this unit. This is made by Mitsubishi, as is the box itself. So this conversion layer here is 100% Mitsubishi. It's literally labeled Mitsubishi, and then it's relabeled a Honda part here. This one's seeing better days, but you can see Mitsubishi Electric Corp. These, again, are a Mitsubishi IGBT. Mitsubishi in the 90s basically led the IGBT game. They were the first to have a really solid one. Keep in mind that IGBTs, I'm not terribly old, and these did not exist when I was born. So they're pretty new technology, the last 30 years as far as, semiconductor devices, the MOSFET, the transistor, is in the 50s. MOSFETs was shortly thereafter, I think the late 60s maybe. These were mid to late 80s. And the first ones were really plagued by issues. You can have latch-up issues with these. Anyway, Mitsubishi was the first to solve it. In the 90s, they led the pack, and that's why they're in the Honda Insight here. And anyway, yeah, so this is the unit that kind of ages out, and this is the one where I was saying that you can get the short circuit over flag or whatever it's called there. These just can kind of wear out over time, particularly when you're overcurrenting them. Yeah, anyway, that is it. This backside here is a cooling plate. It bolts directly to the back of that heatsink. This is the most power consuming device and heat in the car besides the actual motor, the IMA motor. This thing is sinking like kilowatt, possibly plural. I think it's maybe 1700 watts in the worst case that this is sinking into that back plate. Anyway, yeah, that is the PDU, the power delivery unit here, and the IPU. So here's the IPU that's inside of it. This is the pre-driver that is interfacing with the MCM. So that is the parts of this unit.